Jennifer. I'm a graduate student in the Master's of Urban and Regional Planning program.
I'm Declan, graduate student.
When do you get from a second year MURP?
Matt Kroll, I work for the Oregon Department of Land Conservation Development in the Transportation Growth Management Program.
Great.
Chris Monsieur, I'm a faculty member in Civil Environmental Engineering.
Charles Cohen, undergraduate, Civil Environmental Engineering.
Sabrina Gallagher.
Peter Mason with PDOT.
Patrick Singleton, DPS Associates.
Kim Burrows, second year.
Robert King, second year.
Second year.
Julia Person, first year.
Frank Grasser, like Pedestrian.
Sally President, Pedestrian Advisory Committee.
John Lady, faculty member.
Great, so welcome everyone. Oh, we are on camera already. Okay. So welcome to our Friday seminar. I'm Jennifer Dell. I'm a faculty member here in the School of Urban Studies and Planning, and I help co-organize this seminar every week with my colleagues, Chris Monsieur, Rob Bertini, and John Gliebe. We're very happy to have you all here today for a couple presentations by some of our graduating graduate students here in the Masters of Urban and Regional Planning program. I'm going to remind everyone, particularly if you're here for the first time, that we do webcast the seminars, and if you're going to ask a question of the speaker, please use the microphone that's located on most of the desks. Hold the touch button, keep the red light lit while you ask the question so that people who are watching on the web, and we do get people watching on the web, can hear your questions. So we appreciate that. If there is not a microphone near you, find a seat with a microphone, or you're going to have to lean over really far when you ask that question. So without further ado, we have two speakers today. I'm going to go ahead and introduce them both now. First, we have Kate Lyman, who is finishing up her Master's of Urban and Regional Planning degree. She's going to be talking about her field area project on travel time reliability. And then secondly, we'll have Delia, who is also finishing up her MURP degree, talking about pedestrian crossing behavior. Two very interesting projects. So without further ado, and we'll have questions after each speaker.
Thanks, Jennifer. So like she said, my name is Kate Lyman, and I'm a second-year student in the Master of Urban and Regional Planning program here at PSU. And today I'll be talking about the work that I have done for my field area paper. The title of my study is Travel Time Reliability in Regional Transportation Planning, as it says. So I'll begin today by giving some background to my topic and the approach that I took to my analysis. And then I'll go and describe the methodology and the results of the two main parts of my study, the first of which was a content analysis of regional transportation plans from across the nation, and then the second, which was a case study of Portland freeways that I analyzed using travel time reliability measures. And then I'll go through the conclusions and recommendations that I've come up with so far, and I'd be happy to hear any suggestions or comments that you may have. So these are the two questions that I started with. How do we measure congestion, and does it make a difference? The typical measure of congestion is the volume to capacity ratio, which is usually expressed as a level of service category from A to F. Many researchers are now finding that this is an incomplete measure in that it doesn't illustrate the true user experiences of the system and the cost of the variation in those user experiences. So the Federal Highway Administration and other researchers have begun to look to measures of travel time reliability as a way to fill in the gaps from those existing measures. A report published in 2004 by Cambridge Systematics for the Texas Transportation Institute, which was called Traffic Congestion and Reliability, stated that travelers value the variable component of their travel time between 1 and 6 times as much as the travel time itself. And other researchers have expanded on this to say that that variation in how much travel time reliability is valued has to do with differences in household characteristics, trip purposes, and the time of day that the trip is taken. Travel time reliability is beginning to gain some attention within our region as well. The report that I'm sure many of you are familiar with, called The Cost of Congestion to the Economy of the Portland Metro Region, does talk about how costly the variability in travel times is to businesses and industries in the Portland region. The Federal Highway Administration gives this definition for travel time reliability. It states that travel time reliability is the consistency or dependability in travel times measured from day to day or across different times of day. There are several different measures of travel time reliability that FHWA uses. The first is simply the 95th percentile travel time at a given time of day on a given corridor. The second is the travel time index, and this represents the average amount of extra time that it takes to travel at a given point in time, and it is calculated by dividing the average travel time by the free flow travel time. Another measure is the planning time index, and this represents the amount of time that a person needs to add to their travel time in order to make sure that they're on time 95% of the time. This is calculated by dividing the 95th percentile travel time by the free flow travel time. There's also a simple frequency threshold, which is just how often does a certain corridor reach a certain level of travel time. And then finally, the measure that I have chosen to use is the buffer index, and this represents the average amount of extra time that a traveler would add to make sure that they're on time most of the time. And it's calculated, as I show here, by subtracting the average travel time from the 95th percentile travel time and then dividing that value by the average travel time. So to give an example, if you are traveling down a roadway at midnight and it will take you about 10 minutes, and then you say you want to travel around that same roadway at 4 p.m., if the buffer index on that roadway at 4 p.m. is 30%, then you're probably going to allow for 13 minutes at 4 p.m., whereas it would only take you 10 minutes at midnight. So now I'll move on to the first part of my study, and this was a content analysis of regional transportation plans. I looked at 20 RTPs from across the nation, and this represents about 5% of the total number of RTPs. And I chose them to represent both geographic diversity and diversity in terms of jurisdictional size. And these are the three questions that I was looking for. Number one, how do they evaluate congestion? And specifically, do they use measures of travel time reliability? But if not, what measures do they use? And then secondly, how do they prioritize improvements to their roadway system? And I was hoping to specifically look for how they use their congestion measures to influence that prioritization process. And then third, if they don't use travel time reliability measures, is there any mention of travel time reliability in any other place in the RTP? So I won't go through each plan individually, but I will go ahead and present some of the findings that I have from all of those 20 RTPs. Number one, the volume to capacity ratio was used in all plans. It is prevalent and very popular. But many plans did use additional congestion measures, and some of the more frequent ones were vehicle hours of delay and average speed by functional class of roadway. None of them that I looked at used a measure of travel time reliability. However, reliability was sometimes mentioned. Some plans talked about reliability as an overall goal of their system and would mention reliability within either the vision statement for the transportation system or as a specific policy of the transportation system. And also, in addition to that, some regional transportation plans mentioned reliability as a goal for one particular mode. Transit service reliability was mentioned several times, and freight service reliability was mentioned a couple of times. None of the plans used travel time reliability in what I would consider a comprehensive way. And also I would say that a lot of these, particularly the larger MPOs, have enough data to evaluate travel time reliability. They're looking at average speeds, they're looking at speeds by roadway already, so I think that it wouldn't be that difficult to include measures of travel time reliability to what they're already doing. So now I'll go on to the case study that I did of Portland freeways. What I wanted to do here was look at Portland freeways in a way that could provide an example to other MPOs as to how they could prioritize roadways according to travel time reliability. And these were the two questions that I was seeking to answer when looking at freeways in Portland. Number one, how do those freeways compare to each other? And number two, have they gotten worse over time? So I used data from the Portal Data Archive, and I looked at average travel times and 95th percentile travel times to create a buffer index for each freeway. I looked at travel times by 5-minute increments, and they were averaged by year. So I ended up with an average for each roadway for, say, midnight to 12:05, an average travel time for 2004, and then I compared that to midnight to 12:05, an average of 2005, et cetera. It's important to note that both 2004 and 2007 were partial years in my study. Portal didn't start archiving data until midway through 2004, and of course 2007 isn't over yet. So there may be some issues with those 2 years and that the averages might be somewhat skewed. I included all major freeways in Portland with the exception of I-405 North because there are only 2 detectors on that freeway and they're too close together to provide an accurate measure of travel time. So now I'll go through and point out the major trends along each freeway. And again, I'm looking at the buffer index, which is calculated by subtracting the average travel time from the 95th percentile travel time and then dividing that by the average travel time. And it represents a percentage. This is I-5 North from Wilsonville to Jansen Beach. This has a higher buffer index in the PM peak than any other time of day. There were high spikes in both 2006 and 2007 in the PM peak. And in general, I-5 North is pretty reliable during midday. Here we have I-5 South from Jansen Beach to Wilsonville. This has a lower buffer index in the PM peak than does I-5 North, so it's more reliable than I-5 North in the PM peak. It's approximately the same in the AM peak. And here there's really not been that much of an increase between 2004 and 2007 in terms of the buffer index. Here we have I-205 North. It looks here that there's been a pretty severe increase in the buffer index in 2007, particularly in the AM peak and midday. But again, that should be treated with some caution since 2007 is a partial year. And here the PM peak buffer index is lower than both I-5 North and I-5 South. So here we have I-205 South. This is from Airport Way to Stafford Road. Interestingly, it looks here that the buffer indices in the PM peak have decreased since 2004, so this would indicate I-205 South is getting more reliable in the PM peak. And the point in the AM peak at which the reliability is worse seems to be shifting slightly later along here. I-205 South looks like it has a high buffer index in the midday, but in general, this freeway is more reliable than other freeways. Here we have I-405 South, and this is from Front Avenue to the I-5 junction. There's been an intense increase in the buffer index midday for 2007 here, which again should be treated with some caution. There's been a high buffer, there is a high buffer index in the PM peak, even disregarding 2007 data. And in fact, this freeway has the worst rating for reliability of any other freeway. But in general, it's pretty reliable in the AM peak and during midday. This is I-84 East from the Morrison Bridge to 60th. It shows a large increase in the AM peak buffer index since 2004. The PM peak buffer index is high relative to other freeways, but has decreased somewhat since 2004. And I think what's interesting in this freeway is that you can see that the reliability starts to get worse at around noon, and it just keeps getting worse until around 7 o'clock, at which point it gets a lot better. This is I-84 West from 207th to 33rd. There's been a large spike in the PM peak buffer index in 2007. Also, there was an even higher spike in 2004 in midday, which didn't repeat, so that may be indicative of some sort of ongoing construction during that time of day or some other special circumstance. The AM peak buffer index has decreased on this freeway since 2004, but it's still higher than any other freeway. So I-84 West is the worst of all freeways in the AM peak. Here we have Highway 217 North. This is from 72nd Avenue to Walker Road, and it generally has a low buffer index compared to other freeways, and the PM peak index has decreased since 2004. Interestingly, the reliability in the midday for 217 North has gotten worse in 2007. This is Highway 217 south from Barnes Road to 72nd Avenue. It shows a much higher PM peak buffer index than 217 north. The AM peak buffer index has decreased since 2004, although remains pretty high on 217 south here. And there was a high midday buffer index in 2006, which seems to have lessened in 2007, so it might be getting a little better this year. And then here again, like on I-84 East, the reliability starts to get pretty bad at around noon and gets worse and worse and worse until around 7 o'clock. This is Highway 26 East from Jackson School Road to I-405. It shows a high buffer index in both the AM and the PM peak, and the AM peak is much higher in 2007 than it was in previous years. The PM peak has decreased since 2004. And I think what's interesting here is that there are pretty distinct AM and PM peak periods, which is in contrast to the next slide here, which is Highway 26 West, where you can see there isn't much of a peak sort of distinction here. Also on Highway 26 West, there's a pretty large variation according to year. And again, there's just less of a distinction between the AM and the PM peaks and midday. So my conclusions on this study, these are averaged for all 4 years. The PM peak is from 4 to 6 p.m. for all freeways, and the AM peak is from 7 to 9 a.m. for all freeways. Interestingly, the PM peak is worse in all freeways with the exception of I-84 West, and there's a pretty big range of daily values. It ranges from 17%, which is I-205 North, to 37%, which is I-84 West. So if you're looking at it from an entire day standpoint, I-205 North is the most reliable, whereas I-84 West is the least reliable. Looking just at the PM peak, it ranges from 46%, which is Highway 26 West, to 125%, which is I-405 South. So again, in the PM peak, 26 West is the best, whereas I-405 South is the worst. And then in the AM peak, it ranges from 12%, which is I-84 East, to 83%, which is I-84 West. So I-84 East is the best in the AM peak, and I-84 West is the worst. This shows the same data, not for every freeway, but just for the outliers for the entire day. I know it's a lot to see, but you can sort of see that I-84 West stands out in the AM peak, and I-405 South stands out in the PM peak. So my conclusions from the case study: number one, prioritize I-84 West and Highway 26 East in the AM peak. Prioritize I-405 South and Highway 217 South in the PM peak. And then looking at reliability from a daily standpoint, the worst freeways are I-84 West, Highway 26 East, and Highway 217 South. So in conclusion, I'd like to provide the following recommendations to metropolitan planning organizations or to any agency evaluating travel time reliability. Number one, I think it's important to make reliability a system-wide goal within a regional transportation plan. Literature from both the Federal Highway Administration and the Texas Transportation Institute suggests that people really value their time, and the variation in travel time is very costly, especially for businesses that are dependent on just-in-time delivery of their goods and services. So this is what I mean by prioritize travel time reliability. Make it a goal and make it a priority of your system and of your planning process. Second, I would recommend using travel time reliability in addition to existing measures of congestion. I think that it can provide a useful look at the transportation system that may end up prioritizing roadways that wouldn't receive attention in using other measures. And so that's what I mean by evaluate travel time reliability. And finally, I think it's important to actually take those measures and use them to prioritize improvements to the transportation system. These improvements could include better incident management, especially along certain times of day at certain corridors, and perhaps seeing how you could relieve bottlenecks on some of these problem corridors as well. So in conclusion, I think that by incorporating travel time reliability measures into regional transportation planning, we can better understand user experiences of the transportation system and more accurately prioritize improvements into our system. Any questions? Yeah. Go ahead.
How did you calculate the y-axis of the plot, the value of the reliability?
That, I'll go back. It's the buffer index.
Yes, the y-axis, the value.
It's the 95th percentile travel time minus the average travel time, and then that value divided by the average travel time. Yes?
So the average travel time is taken over 24 hours.
No, the average travel time is for that 5-minute period. So, so it would be the 95th percentile travel time within a 5-minute increment of, say, midnight to 12:05, and then that minus the average travel time for midnight to 12:05, and then that entire thing divided by the average travel time again. Delia?
Did you look into possibly why the travel time reliability was differed between the different freeways that you looked at? Why one was worse than the other? I mean, did you look into like places that people might have been going, if there was a high incidence of crashes on those freeways, or whatever might result in poor travel time reliabilities?
I didn't. I think that's a little bit outside of the scope of my study, but I think that would be the logical next step to see why travel time reliability is bad on these corridors, and that would help to prioritize, figure out how you could really improve it. I mean, whether it's a bottleneck sort of situation or what. That's a good idea. Kim?
I might have missed it, but why the 95th percentile?
Well, this is a measure that is suggested by the Federal Highway Administration. So they suggest using all of these measures, and I chose the buffer index because I thought it was a little bit more nuanced than either just the straight 95th percentile travel time or a frequency threshold. But to me, it was a little bit easier to understand than some of their other indices. So it isn't, I mean, I didn't make up the measure. It's the FHWA approved measure. Wendy?
Do you by any chance have any thoughts or ideas about why this travel time reliability is not used in the transportation plan that you looked at, especially when it's mentioned as, you know, one of the goals or one of the visions? You think that as such they would use it?
I think it's just sort of starting to gain momentum. There's been a lot of recent literature coming out on travel time reliability, so I think it's just a matter of people becoming aware of these measures and their importance. So I think in 10 years, then a lot of RTPs will include stuff like this. Yeah.
I'll just comment on that because I happen to know comment on the last two questions, if you don't mind.
No, please.
Many MPOs actually don't measure speed. They use count data that they convert to speed. So they don't have the whole histogram of all the speeds that we do when we have the sensors on the freeways. A lot of cities have instrumented freeways, but the MPOs are not using those data to do their monitoring. So the volume-based speed calculations are really rough and questionable. And the other thing about the 95th percentile is that translates to the idea that if you allow for the 95th percentile travel time, then on average you'll be late once a month. And that's sort of how people grasp that idea. But the question I had for you was, in your final ranking of or highlighting of several corridors as needing attention in terms of reliability, have you thought about how if you had a similar ranking just due to volume to capacity ratio or just due to the travel time index, then how would you, so you could rank the freeway corridors by travel time index or congestion and by reliability, how might you combine those or weight those two to come up with sort of an improved ranking? Because right now everybody ranks on volume to capacity, you have the ranking on reliability. How would you merge those?
Well, I think a lot of them might be the same corridors. for one. And that might be why a lot of these corridors are not very reliable, is that there's just simply too many cars trying to drive on them. I think it would kind of depend on the MPO and what they're trying to achieve. If they're just trying to achieve highest speeds on their roadway, then maybe prioritize V over C kinds of measures over reliability. But if they're trying to look at sort of a customer service kind of a standpoint, then maybe they might prioritize reliability a little higher. I don't think there's one way you should do it necessarily. Yeah.
Well, I think also the typical capacity measures are based on the highway capacity manual, or unless you take into account the variability capacity brought on by incidents and that sort of thing. So I think that would be an interesting comparison to make, because it would give you sort of a steady state version versus the actual measures. So yeah, for anybody who's looking for a paper, I think he's on the paper. I'm not.
Yeah.
Did you use data from all 7 days of the week or just weekdays?
I believe it's all 7 days of the week. I got Portal does an average for you, so they were nice enough to just provide me with averages that were monthly, and I believe it's from all 7 days of the week. But Rob could probably clarify that maybe.
You can, within our system, you can pick either weekdays or midweekdays or all days or weekends. But I believe this was just all 7 days.
Mm-hmm.
Could you speculate on how it might change if you did have just the 5 days?
It probably, a lot of these places would get worse. I mean, I would think that the reliability is probably higher. It's better on the weekends. Congestion tends to be less. So, I mean, I think that it might exaggerate some of these differences if we were just looking at 5 days of the week, the weekdays. Maybe not.
I would think that having the weekends in there pulls the average down.
Right, that's what I mean.
The 95th look higher. So if you dropped the weekends out, you wouldn't have as much variability. But I don't know, I'm speculating.
Got 3 papers.
Yeah.
Yeah, I wonder why the PM peak periods are worse than the AM peak ones. I mean, why there should be more congestion in the AM peak periods?
I think there's just in general more travel happening during the PM peak, more non-commuter related travel. And in a lot of these places you're seeing the PM peak spread a little bit further than the AM peak. So I think that might have something to do with it. I think our professors could probably elaborate more, but I think in general there's just more travel in the PM peak. Yeah?
Kate, when we're looking at the graphs and you look for specific facilities and you saw that, for example, I don't remember, but some of them changed over time, okay? And you pointed out a few where, well, this particular facility became less reliable or had a sharper peak in 2006, 2007 than it did in the past. Then there were others where it actually improved reliability during one of the peak periods. Did you do any sort of poking around at the corresponding volume data to see if the changes corresponded to a change in demand on the facility? Or, I don't know if you have that available, or do you have any other thoughts on what might be the root cause? If it was just a change, fluctuation in demand, or were there other factors?
I think that would be a great next step to look at the demand for these corridors. I didn't look at that as part of this analysis. I think in a lot of cases there may be some special circumstances, maybe construction going on that I would have to look more closely into on some of these corridors. But I mean, maybe it's just people, variations in population around some of these corridors and actual travel on them, and I think that would be really interesting to look into next.
They did widen the 26, of course, between 04 and 05, and also ODOT has changed their rent metering software in the 05, 06 period. So it seemed to me some things were probably attributable to those factors.
Yes?
Well, additionally, if the travel gets increasingly bad over time, the index drops because there'd be less variability between the average and the 95th. It would seem. In other words, if it's awful all the time, then the index drops.
Sure, yeah.
Any additional questions? Thank you very much, Kate. So we'll have our quick transition to
Okay, thanks, Kate. You did a good job. My name is Delia Chi, and I'm also a MURP student at Portland State University, Masters of Urban and Regional Planning. And what I've chosen to do for my field area paper is to study the effectiveness, the safety effectiveness from a behavioral perspective of marked versus unmarked crosswalks at unsignalized intersections. That may sound like a mouthful, but hopefully by the end of the presentation you'll understand what that all means. I'm going to be going through the rationale for why I have chosen to study this project, some background research, and a description of the study sites that I've studied, my methodology, and my analysis and the next steps. So one of the reasons why I decided to choose to do this study is because I was doing a lot of research and I noticed that there's a lot of controversy out there on whether or not marking crosswalks are effective treatments for improving pedestrian safety. I mean, you can think that if you put in a marked crosswalk, especially at an unsignalized, where there's no traffic signal, intersection, cars who are going to be vehicles who are going to be coming down the street are going to be able to see the pedestrian because the pedestrians are going to be in a more visible location. You may think that the pedestrians may feel safer walking. There's a lot of different issues, but there's also other issues where, pedestrians may have a false sense of security, that they decide to, maybe they decide rather than to walk across, they decide or to look both ways before they walk, they just decide to walk. So there's a lot of controversy about whether or not marking crosswalks are actually effective treatments. And then the other thing I wanted to do was to add more data on pedestrian crossing behavior. A lot of research out there has focused on looking at evaluations based on crashes, and not a whole lot has been done on behavior. What I wanted to do was to add to the behavior data that's existing out there, because the behavioral data, I think, is going to, if you look at it in comparison with the crash data, it's going to give you a better picture of exactly what's going on in the intersection. So one thing I wanted to do was to add more to the data out there that's on behaviors for pedestrian crossings. So the research that's been done before-after evaluations on pedestrian safety crossing is the ones that have been focused on crashes. A lot of them have been focused on crashes have shown an increase in pedestrian collisions after the treatment. That's not a good thing. And what I've noticed was, after looking through a lot of the different research, some of the researchers' names are down at the bottom of the screen, is that a lot of them studied high crash locations. So the after effects of a treatment might be different than if you were just randomly selecting various locations throughout a city. Also, a lot of them didn't actually study the behavioral aspects, but a lot of them alluded to the fact that we found this trend increase in crashes, but it could have been a result of a change in pedestrian crossings at their attitude, but they couldn't really elaborate on it more since that's not what they studied. And then finally, I noticed that a lot of the studies that have been done in the past focusing on crashes did not control for intersection or crosswalk configurations, the geometry. A lot of them kind of or the volume. A lot of them kind of lumped it into mass studies where they looked at a lot of, like 400 different intersections. But all the intersections, the geometry of it were a little bit different. The crosswalk treatment types were a little bit different. The volumes were different. So that's what I've those were the three things that I noticed looking at before-after evaluations based on crash data. So for the before-after evaluations based on behavioral data, the first study actually came out in 1975 that somebody named Katz, a researcher, he looked at pedestrian crossing behavior, but his wasn't a before-after evaluation. He noticed that vehicles did stop more. They slowed down when there was the presence of a marked crosswalk. But he was one of the leaders in I guess, having the behavioral aspects surface. And then it wasn't until 2001 where a researcher named Knobloch, and he also did some work for the Federal Highway Administration, looked specifically at behaviors at unsignalized intersections and the effects of marking a crosswalk. And so the behaviors that he looked at were pedestrian crossing location, and here he looked at whether or not the pedestrian had a mid-block crossing or they actually used the crossings at the intersection. Another thing we looked at was the vehicle speeds and traffic gaps. He had access to the speed detection devices. So he looked at vehicle speeds coming down the road, looked to see whether or not what the acceptable gap was for pedestrians who would feel safe enough to cross the street. And also by collecting the speed information, he was able to determine whether or not vehicles yielded and gave right-of-way to a pedestrian. And then finally he looked at pedestrian crossing behaviors such as their travel path, which is how often do they actually, when they're in the crosswalk, how often do they actually stay in the crosswalk? Their gait, which is pretty much do they run or do they walk? And then he gathered the demographic information, age, sex, and the whether or not pedestrians were traveling in groups or they were traveling by themselves. His results pretty much showed that there was not a huge change between after the crosswalks were marked. Drivers did approach pedestrians more slowly. He did find that the crosswalk usage overall did increase after the markings were installed. But again, he didn't really find a whole lot of evidence showing that there was an improvement in pedestrian safety. But also, he didn't find any evidence that pedestrians displayed a false sense of security and were careless in their crossing behaviors. So for my research, I used the Knobloch study as a basis for my research, looked at the same types of behaviors that he looked at with some modifications. And so I'm looking at a before-after evaluation of the safety effectiveness of crosswalk markings. And so, like Knobloch, I'm observing and comparing the changes in various vehicular and pedestrian behaviors. So when I started the study, I spoke with PETA, and they let me use video footage. So what they did was they mounted some videos at some of the intersections that I was studying at, so I wouldn't have to go out there and actually collect data, sit there for hours and hours at a time and collect data. And so some of the criteria that they used to select sites to mark crosswalks across the Portland area was that the site had to be classified as a community main street. It had to be a neighborhood or district collector street. The segments were greater than or equal to 4 blocks long. There were 2 travel lanes. The average daily traffic volumes were 8,000 to 15,000 vehicles per day. The pedestrian weekday flow rate was greater than 200 pedestrians per hour. And for me, I added the last criteria, which is it was a feasible location to set up a video camera, because a lot of places there's a lot of obstructions like trees, or there's no utility pole in the area that you can actually mount the video camera on. So that was my added criteria. So the study sites that I chose to look at were in the northwest area because they were close to where I was living at. And down in the southeast area is downtown, and then to the south is Burnside. And then the 2 study areas are in northwest Portland, and I looked at Hoyt and Johnson on northwest 21st Street. So I was primarily looking at the major street, which is northwest 21st. The minor streets are Johnson and Hoyt. Here's a picture of Northwest 21st and Northwest Hoyt. This is a picture looking south. This is a picture showing, in this intersection, you see the Sandside Japanese sushi restaurant on the corner, but there's some stores on the other corners, and also some residential apartments. And this is a picture of Northwest 21st and Northwest Johnson. This just happens to be looking north. On the bottom, the left corner there is the City Market. It's a grocery store. There's a restaurant on the opposite side. There's a cleaners with a parking lot on the far side, the side that's further away from you. And then there's a residential apartment complex that is the building that you're seeing right now. Comparison of the two sites. I took the data from PDOT, the average daily traffic and the pedestrian volumes. A lot of this was recorded either in the summer of 2006 or in 2001 and 2004. And the average daily traffic on both the intersections, the two sites are only one intersection apart from each other. So I pretty much said that the average daily traffic was about the same at 10,000 vehicles per day or 879 vehicles per hour at the peak hour. And then the pedestrian volumes were 380 pedestrians per hour going along the street both ways. The number 4-year crash data indicates that, and this data was 2000 to 2004, indicates there were 18 vehicular crashes on Hoyt and 9 on Johnson, and then neither of the sites had any pedestrian crashes in the past. The speed limit at both sites was 25, 2 lanes. The major streets at both sites were unsignalized and uncontrolled, meaning there were no stop signs on the major street on Northwest 21st. And then the minor streets were stop controlled. At Hoyt, it's a one-way street, and at Johnson, it's a two-way street. The curb types, both of them have ramps on their curbs where the crosswalks are located. They're pretty old, but at Johnson, one of the crosswalks actually has a curve extension, and you can see it right there on the far side. And as I said before, both of the areas are accessible to a lot of restaurants. There's residential, there's a lot of stores, and then they're both accessible to transit, but neither of the locations actually has the bus stop at that location. The times that my study times were, the video footage was captured from 7 a.m. to 8 p.m., but the times that I actually studied were 4 times throughout the day, spread out, daytime hours, 8:30 to 9 o'clock, 11:30 to 12, 2:30 to 3, and 5:30 to 6 p.m. And below here in the chart, I have the dates that I actually captured video footage. And so I captured the before video footage in late March. The treatments were installed April 5th, and then I captured the after video footage at the end of April. My methodology, like I said, I used no-block study, and I looked at the same types of behaviors that he was looking at. So I looked at the volume counts for pedestrians and vehicles, and then I looked at the total number of pedestrians utilizing the crosswalk. 2 variables that I added are shown in red. It's the curb duration and the driver's yielding when pedestrians are at the curb. So the pedestrian variables, I looked at the curb duration, how long the pedestrian was waiting at the curb before they crossed. And I looked at the pedestrian attentiveness, how many times did they look before they actually crossed. And I did this when they were at the curb and when they were at the mid-block. Their travel path, whether or not they stayed in the crosswalk, their gait, walking, running, and then I captured the demographic information. The driver variables, I looked at the drivers yielding when pedestrians were at the curb. What I actually charted was the pedestrians who were not yielding, or the pedestrians who actually passed the vehicles who were actually past the pedestrian, who had a chance to yield because they were in front of the crosswalk, but did not yield to the pedestrian. And then I actually looked at, for the whole event, whether or not the drivers yielded, and then finally the gap distance. In my methodology, as I said, I watched video footage of the pedestrian crossings. It was many hours of watching video. And then I recorded the data on sheets of a drawn intersection. I recorded data by pedestrian crossing event, and I separated the near side and the far side out. And then I transferred all this data into Excel. Here's a picture of my drawn intersection. So the bottom side of the screen is the northbound direction. And the only reason why the north is flipped to the bottom is because that's the direction that the video camera was taking footage of. So it was easy for me to record data that way. So the left side of the screen is the northbound direction of the vehicles traveling northbound. And then the right side of the screen, the vehicles are traveling southbound. And so each of the lines for instance, in the northbound directions, there's 3 lines. So there's 3 vehicles, and from left to right, it's the first vehicle going straight, the second vehicle going straight, and then the third vehicle turning. Here, the black line that's across the curb extension is the pedestrian's travel path. And I indicated with the arrows whether or not they looked, the demographics. So for this event, it's all hypothetical. It's 2 adults, male, female. And then I indicated all the numbers that you see on the screen are, the small numbers are the times that they actually, in second, of the event. So the start time for this event was 11:54, and then 34 seconds. So likewise, I wrote down all the times where the pedestrian was, or the vehicle was at the different areas. The zones that you see down the middle are, I separated the study site into 10 different zones. Each zone is approximately 1 vehicle length long, and that helped me determine where vehicles were actually placed. Without the resource of having a speed detector device, this is the best that I could do. In my analysis, as of today, I only have the data for 1 intersection, which was Johnson. Into Excel, I have I've drawn everything out. It's just the only information that's entered is Johnson. And Johnson, there are 490 crossing events. So total number of vehicles during the pedestrian crossing events, this is on major and minor streets. The bottom, the x-axis, you can see the 4 different times throughout the day that I actually did my study at. And the before treatment, there were 838 vehicles during the pedestrian crossing events, and then 912 after. You can see the trend throughout the day is that the vehicular volume goes up by the end of the day, which makes perfect sense. Likewise, on the major street alone, the number of vehicles increased after the treatment, but only slightly. I didn't think it was a big difference. 625 to 712, and again, the trend number of vehicles increases as you proceed through the day. Total number of pedestrians at crossing events before the treatment and after the treatment, there were 237 and 253. So again, it follows the same trend as the vehicles, that there's more pedestrians crossing throughout the day. This shows the total number of pedestrians. The slide before was showing the number of events that I was looking at. So if people were in a group, they were counted as 1 event. So this just shows the total number of pedestrians, and it follows the same trend. Here I look at the total number of pedestrians by curb waiting time. So this is the amount of time that they waited on the curb before they crossed. And so the average waiting time before was 3.41 seconds, and then after was 2.68, which just means that pedestrians spent less time waiting on the curb after the treatments were installed than before. This is a similar chart, but showing the pedestrian who is at the curb. I noticed that a lot of pedestrians, they were on the curb, they stepped off, and they waited while they were in the crosswalk. So this is the same chart, but it's showing the time that a pedestrian took before they actually crossed into and started their travel path to the end of the crosswalk. So here again, they spent 4.38 seconds before waiting, and then 3.34 after. This is the number of looks per pedestrian, so it's judging the rate of pedestrian attentiveness. So you can see the trend throughout the day, but the average is 1.39 looks per pedestrian versus 1.05 looks per pedestrian after the treatment. So it decreased slightly. The rate of pedestrian attentiveness at the midpoint, the preceding graph was at the curb. This is at the midpoint. So actually more pedestrians looked at the midpoint, 0.13 before and then 0.17 after. And more people looked, especially you can see at the 2:30 to 3 o'clock time period. This is the percentage of time pedestrians actually stayed inside the crosswalk area. I noticed that pedestrians do stay inside the crosswalk area more after the crosswalks were marked. The average was 71% before and 86% after. I looked at the time they stayed in the crosswalk at the curb, when they stepped off the curb, at the midpoint, and then at the end. This is a chart showing the total number of runners. So the total number of runners decreased after the treatment. Everybody else walked. What I thought was interesting was looking at the 4 different time periods. Despite the number of joggers that are in the morning, because I counted them as running, of course, more people run in the afternoon than they run in the morning. I thought that was pretty interesting. The total number of vehicles on the near side who did not, this is the number of vehicles who passed the pedestrian and while the pedestrian was on the curb and did not yield. So there was an increase from 11 to 37. This last chart shows the average percentage of all vehicles who yielded during the entire crossing event. So this actually shows something different than what the last chart showed before. The chart before was showing that there was an increase of people not yielding. But this chart shows that people actually yielded a little bit more after the treatment was installed, from 40 to 51%. This is a summary of all the data that I've just presented. And everything in white is there was an increase. So the first 4 are all the volumes, so those all increased slightly. And then what's shaded in blue is anywhere that there was a decrease. So that was curb waiting time, the waiting time, the number of looks per pedestrian at the curb, and the total number of runners. I then compared this to the results that No Block had, and they were all the same except for the values that are in red. And the way that I explained it is it wasn't really comparing apples to apples. In No Block, I was looking at total number of runners. He was looking at total number of aggressive behavior. So it's not entirely the same comparison. I found a decrease. He found an increase. And then the total number of vehicles who did not yield when the pedestrian was on the curb and who passed the pedestrian. I found an increase. No Block didn't study exactly what I was studying. So those are the 2 differences. My next steps is the additional analysis that I have to perform. This is preliminary analysis or preliminary results. And I need to add the data from the Hoyt intersection, but I'm guessing it'll probably be about the same. And then I have to complete my statistical tests on it. I do want to thank Professor Jennifer Dill, Christopher Monsieur, and especially PDOT, who have helped me throughout this whole process, Cliff Bowling, Rob Birchfield, Tom Jensen, Sabrina Cow, and Sally Seeger. And then the students, students I'd like to thank are listed at the bottom. They helped me think through a lot of these issues. They provided me with a lot of research articles that they found. So I was very thankful for all the help that they provided. And then I guess the last thing is just be safe when you're walking, yield for pedestrians. Any questions? I guess you were first.
This seems rather odd, but you're saying that the near side, if the person was standing at the curb on the near side, yeah, this is good. That when they're standing there waiting to get into the crosswalk, more drivers actually ignored the crosswalk after the treatment than before?
More drivers. What the the second from the bottom one, is showing that when the pedestrian was on the curb, there were a number of, I counted the total number of drivers from the start of the event. And the start of the event is either 2 steps behind the front of the crosswalk, or it's when I noticed that they were actually going to cross. And so it's the number of cars that actually passed before somebody actually yielded, which I thought was pretty compelling. It's like that many people crossed. And it's, I mean, maybe the driver didn't see the pedestrian, there's that issue. But if they actually saw the pedestrian,
Doesn't it, I mean, in this case, doesn't it, it seems like, the addition of the crosswalk is actually more dangerous to the pedestrian, not because the pedestrian is there, but because the drivers are just ignoring it.
Yeah.
But wait a minute. Your volumes of crossing and your volumes of vehicles also went up.
Right.
So those just showing the raw numbers went up. It's going to be somewhat related to your volumes going up as well.
Right. One thing that I was thinking about.
If the behavior just remained exactly the same, those volumes are going to go up because your volumes of cars and your volumes of pedestrians also went up.
Right. One thing that I was thinking about doing was dividing it out by the volumes, but
then your percent.
Right.
And that, I mean, shows what I think is more valuable to look at is that a higher percent of the vehicles yielded. And that is showing a change of behavior that takes out the fact that the volumes change.
That's during the whole event, though, not just at the very beginning of the crossing. Joe? Okay.
I want to know the before and after treatment, how people make it, because I mean, does the treatment mean the presence of the crosswalk? I mean, before it was present and after it was marked?
I'm not sure if I understand your question, but I think you're asking is the before.
Yeah, I mean, what is meant by the treatment?
Well, the treatment is the marking, the crosswalk marking.
So they weren't there?
They weren't there before.
Okay, so you took the data from recent years or something when they weren't there?
Yeah, in the this is the before, the video footage that I captured before. That was before the crosswalks were marked, or before they were painted. And then the after is after they were painted. So I captured data before and after.
Oh, all right.
Does that answer your question? Okay.
Okay, so a few close to my heart. I pay a lot of attention to pedestrians, and I teach pedestrians how to cross the street. So the title of the paper wasn't clear, or your study wasn't clear whether it was pedestrian or driver behavior. It became apparent as you were reporting, but you might want to clarify to include pedestrian and driver behavior. My specialty is teaching pedestrians who have little or no vision, so they don't turn to look to see if there are cars, many of them. They rely on hearing. So you might, that would be an area to look at is, you can't see that on the video, but are people using a greater sense of the environment? You didn't define treatment very well at the beginning, but it became clear through the paper what is a treatment of an intersection. And again, I'm not in the field, so and you also didn't identify whether or not there was going to be shelter at the center of the intersection, although you did say it was a two-lane crossing situation, but there are some two-lane crossing situations in Portland where shelter has been provided midway across the intersection.
There was none.
Right, there wasn't. You and I know that.
Oh, okay.
Vehicle speeds, gaps, and whether or not there was shelter for a pedestrian to stand at. Anyway, I think there's probably a lot more that could be looked at in terms of pedestrian crossing. Like I said, field of vision and hearing. Aggressive behavior could also include not just runners or speed, the speed at which they're approaching the intersection, but whether or not they turn to look at cars. Because I know as a pedestrian, I don't turn to look at cars. I rely on my hearing and my field of vision, and I think that's interpreted by drivers as aggressive behavior, and I like that. They stop. So don't know how that data.
I didn't look at it. There was no sound, or I couldn't tell whether or not the pedestrian could hear the driver or could not hear the driver in the video. It's just a limitation of the methodology itself.
Thank you for the great
Kim?
I know you're still in preliminary analysis. Can you find any differences by demographics?
I actually did look into the gender, the number of groups. There weren't very many groups to begin with. There are more groups at the end of the day than there were in the morning, which to me makes perfect sense. You know, people are going out to restaurants at the end of the day. But I didn't see a big difference. Either I didn't see a big difference. For instance, the male versus female, there wasn't a big difference between male behavior versus female behavior when I was playing around with the data. And then either that or there weren't enough counts to begin with to actually make a valid conclusion. So I didn't present that. Wendy?
My guess is you probably haven't done this yet, but are you going to look at just something I noticed was that, so although there seemed to be like some increase in the vehicles yielding, there seemed to be an increase of pedestrians not, looking both ways or whatever like that. Are you going to look at kind of like those distinctions? Basically the false sense of safety and pedestrians just going. Are you going to look at that at all?
I guess what do you...
Well, I guess what I was saying is that, you've noticed that with the crosswalks, drivers do yield, at least percentage-wise, some bigger percent of them yield. But it looked like, and I don't know if you called it out or not, that less people look both ways, or there's at least less time waiting at the curb before you go, which may be an indication of a false sense of security. Like, there's a crosswalk here, people will stop. Are you going to kind of compare that at all and look at that?
Well, I did look at I don't know if I'm answering your question, but in the before-after comparison, I did note that the false sense of security would be like if they looked less, which actually happened while they were at the curb, that might be an indication of false sense of security. Whether or not that actually is, I can't really say. Okay. But there's a lot of indicators here of false sense of security, including the looks. Maybe the curb waiting time would indicate a false sense of security. But I can't, maybe if all of them showed a decrease afterwards, or a negative, result, then maybe I could say there actually is a false sense of security, but I can't definitely say there is a false sense of security.
And I guess be a little careful there, because if they're spending less time at the curb, they have less time to be looking, right? If they're there for 1 second less, then they may, so that's going to affect it. And if, I think we need to, as part of your analysis, and this is preliminary, I think it's quite interesting the numbers you found. Looking at that number of vehicles on the near side that did not yield, I think maybe looking at that in terms of percent and see how that changed and if there's a significant difference. Because if the other way to spin this or to look at it is if drivers, the higher share of the drivers are yielding, then you don't have to spend as much time at the curb. You don't have to look, you can just look once in each direction instead of twice in each direction. That is what you should be seeing, right? If the crosswalk is having the effect that you want, people should be waiting less, they should be looking less, and they should be, getting across quicker.
Right.
Isn't working.
Some of them don't work.
Anecdotally, did you see, outside of your count, different kinds of behavior from the pedestrians before and after the treatment?
One thing I did notice was that a lot of, especially at Hoyt, when I was watching the video footage, is that a lot of pedestrians will step out into the curb because there's parked cars on the sides of the street. No, they'll step out in the curb and then they'll stop there and then they'll look because they don't have the visibility with the parked cars being there, or maybe they don't feel like they have the visibility to see, so they will actually step out into the curb before. And the only reason why I really picked this up was because of the curb extensions that were on Johnson, where I noticed, even just on Johnson, because one crosswalk didn't have the curb extension while the other did, and comparing the crossings that were going across at Johnson, a lot more people stepped out into the curb and waited and looked before they crossed at the crosswalk without the curb extension than they did with the curb extension.
Because in Oregon, the law is if you're in the crosswalk, then the cars are supposed to yield, so it's legal for the pedestrians to enter the crosswalk.
Right. Yeah.
So the behavior change is more due to the curb extension than to the, and is that in part of the treatment?
I can't say for certain, but possibly. Yeah, because that wasn't what I was actually studying. Yeah. Chris?
I think you might want to mention that the gap study that you haven't done yet.
Okay, there is a gap study that I haven't done yet. It's looking to see the acceptable gap distance between when the pedestrian is on the curb. A lot of gap studies, you're supposed to look at the flow of vehicles that are going through the intersection, but because of my methodology, I don't have the exact flow of the vehicles. I only have what's going on in that study zone, in that study area. So my modification of the gap acceptance distance was to see, what I did in my data collection was by looking at exactly where vehicles were at different seconds, I could see how many vehicles were in which zone. And from that, I can calculate the gap distance on each, there's 4 different corners where a pedestrian can start crossing. So I can look at the gap distance at the intersection when they actually start to cross. So it's one thing that I'm actually going to be doing. So. Rob?
This might be a silly question, but did you anecdotally notice a difference in clothing color, bright versus dark?
No, but I did. Well, no, not a difference between bright people would behave differently than
vehicles yielding if people had light-colored clothing.
No, the only thing I did notice I thought was kind of funny was there was a guy who was wearing neon yellow. I don't think he was a jogger, but he was wearing neon yellow. Maybe he was a bicyclist and didn't have his bike with him. But anyway, he ran diagonally across the intersections several times at both Hoyt and Johnson. So I knew he was like either, I don't know, making the rounds or something, because he did this twice. And that was the only time that I really actually noticed the color, because it really stood out. But no, other than that, I didn't notice the clothing that people were wearing as having an effect on yielding.
Any additional questions? Did you notice whether there were crosswalk signage markings at the crosswalk?
There are not. There's actually been studies that have been done showing that even though crosswalk markings or treatments may show that there isn't really a big change in behaviors before and after the installation of the treatment, a lot of the studies that, well, one namely, that shows that the signage, if you include signage saying, please stop please stop for a pedestrian, those types of signage are going to be a lot more helpful in changing the behavior.
My other question was there a big difference in weather? It's just about a month difference when you did the before and after studies, but would weather affect the number of pedestrians?
Possibly. In the before, in both time periods that I surveyed, there were spotty times where there were showers, especially in the mornings where it rains before and the ground's kind of wet. But at least during the times that I was actually observing the data, it didn't rain. So yeah, there were little spot drizzles, I guess, if you could call it, enough to get the ground somewhat wet throughout the day, but that happened before and after. So I didn't think weather was a huge indication. My only, I guess what I would say as why the volumes went up is just the time of the year. More people, it's, April, it's springtime, people decide they want to go out more in April maybe than in March. But I can't really explain the increase in the volumes.